Hi, good evening, everyone. Thank you so much for joining the series of talent workshop that we're holding. This is the second series of workshop. The topic for today's session is architecting a data management platform and the required components and services. The session will be presented by Luca. Redington is the largest distributor for all talent-related services across Middle East and Africa. So if any queries, you can always put them in the Q&A tab on your left, and they will be answered at the end of the session. All right, over to you, Luca, please. Over to you.
All right. So can I start?
Yes, please.
So thank you, everyone, first of all. I'm Luca Tamburrano. I work with Brian Perrins in Middle East and Africa. And today, so this is, as it was said during the introduction, this session is for introducing you to what is the concept, what is the concept of architecting a data management platform. So since we have just 1 hour and even a few minutes less, it won't be a deep dive into the different architectures, but I want to give you an overview that starts from the concept of data, because I think that this is important to give you a context for understanding what is data management platform and why there are the different architectures that I will present to you. So first of all, what is data? Data basically is it can be defined as information or simply as a container of information. And actually, it can be a generic concept as facts, number, or even information can be in an electronic form that can be stored and used by a computer. So what is information? Actually, information is knowledge. So, let's say that you have a phenomenon, and information is the level of understanding of such a phenomenon. Okay, and so a phenomenon can be a subject, a place, a situation, anything that can be somehow defined with data, and then that can be derived as knowledge. Now, when we are talking about data in the electronic format, we have basically two main branches of kinds of data. We can have unstructured data, and unstructured data basically is data that is in an unprocessed form. So it can be text, can be mail, can be Word documents, videos, audios, etc. While we have also what we define as structured data, that are data that have been already processed somehow. So can be database tables, can be the formats that I'm sure that you know very well, that can be CSV, JSON, XML files, so hierarchical and non-hierarchical formats, and so on and so forth. And basically, what organizations need to do, since data, as I was saying before, it can be defined as a container of information, individuals and organizations need somehow to extract this information from data. And in order to do that, they can be helped using some software tools. And then at this point, the concept of data management comes into the game, because actually data management can be defined as all disciplines that are related to managing data as valuable resource, because actually are all the disciplines that can be that are somehow trying to define a methodology for extracting this information from data. It starts in the 80s, when from sequential processing, we passed to random processing. Actually, I don't know how many of you remember the Commodore 64. The Commodore 64, actually, I was playing games. And for playing, and these games were stored into tapes. And so actually what you were doing was pressing play, And then you were waiting for probably 15 minutes. And then once the game was loaded, you were able to play the game. And actually the game was stored in a sequential way. And so if anything was happening during this sequence, you had to roll back to the beginning and then playing the game again. But actually the technologies changed. And so we created some kinds of storages that allowed us to access to random locations instead of having the needs of processing data from the beginning until the end. And this is where data management came into the place. Now, when we are talking about data management, we are talking basically about 6 main phases that can happen also in different sequence. And these phases are fundamental to understand the architectures that you can have in data management. So you have the acquisition, the validation, the storage, the processing, the sharing, and the governance of your data. And actually, in the past, this happened using manual coding, but the more the data became complex, the more the use cases became complex, the more there was the need of overcoming the manual coding. That is actually still used, but it's been demonstrated that there is a threshold after which the manual coding is not sufficient anymore, and is not cost effective. And this is why in the market we started seeing some dedicating platforms for managing all these phases. Now, let me go more in deep on all these phases, because each phase will have a different part into the data management architecture. So the first one is the acquisition of data, the data ingestion. And actually, the acquisition of data is quite intuitive, means acquiring data from different sources. And actually, the modern data management architectures, of course, they need component connectors in order for acquiring data from different sources. And this kind of components mainly vary depending on the 2 dimensions. The first one is the nature of the data. And actually here we are seeing that the nature of the data, what I mean is standard data and big data. I will talk a little bit more in depth what is big data. But what is standard data can be anything. So it can be, as I was saying before, can be a file, can be a database table, and so on and so forth. Well, the second dimension is the speed of production of the data, because there is a big difference between, for example, producing 10 records every day and producing 10 million records every hour. And it comes with different challenges, because on one end, you have that the nature of the data can, as I was saying, can be standard data. So you can have a very small table, 100 row, 5 columns, okay, few kilobytes of data. When we are talking about big data, we can talk about terabytes of data that need to be processed, as well as the production, as I was saying before. So basically, a modern data management platform, of course, needs to provide all the instruments for acquiring data from these different kind of sources. So just to give you some examples, database and data lakes, direct connectors, non-structured data connectors for reading files, media contents. Imagine if you need to read, for example, streams that are coming from cameras in the airport. API clients, this is a very important part, because starting from now I would say probably about 20 years ago that we started with web services and then REST APIs. What was realized is that the best form of integrating different sources is exposing services. And this is why a very big part of acquisition of the data are the API clients. So that can be for REST APIs, I was saying, web services. And actually, these can be used for any kind of data that can be structured, unstructured, no real-time or real-time data. And actually, these API clients nowadays need to implement also many kinds of security guidelines. For example, OAuth connectivity, SAM, and so on and so forth. Then, last but not least, also what here I wrote as a message queues connectivity, especially in the IoT context. Imagine that you have, for example, different devices, and these devices have sensors, and these sensors are producing an enormous amount of data. What happens is that the best technologies that are most used for this kind of situations are called message queues. And I think that probably most of you already have heard about Kafka. Kafka, for example, is an example of queue that can be used for storing high-velocity data that are coming from sensors. And on top of this queues, there were different also technologies and protocols that have been built, like MQTT, for example, that is used for IoT contexts. The second part is the validation. And the validation, usually we think about the validation, when we talk about the validation, we are talking about profiling data. That means checking the data against two main classes of rules. Rules that can be technical rules. For example, you want to validate that in a specific field there is a phone number, and this phone number needs to follow a specific format. Or for example, in a field you want a date, and in the date you have the first 4 digits are the year, the second ones are the month, and the third one are the day. And so these are what we can call technical rules. But on the other hand, we can have also business rules. So regardless, for example, that in a specific field you have a correct format, it might be that in the business context that you are targeting, actually you need, for example, to have that if one field has a specific value, another field needs to have another value. Here, for example, I mean an example. If the country field is USA, then the field that contains the cost center of an acquisition, for example, needs to be USA CC. And actually, the validation phase in modern data management architectures is usually the phase that happens right after the ingestion phase. Not always, as I was saying before, these different phases can happen in different order. But usually what happens is that you extract the data from the different sources and you validate them. It can happen also that you can validate the data in the sources first before acquiring them, so before ingesting them into your system, and then deciding to perform ingestion afterwards with specific rules. Usually, this discipline is well known as data quality. Then the third phase, or the third important part of a data management platform, and then of a data management architecture, is the storage. The storage is the key point, because actually the storage represents the container where all this data is actually placed in order to be processed afterwards. And storages can be really many kinds. So you can have, for example, SQL databases and the data warehouses built on top of them for the structured data. But you can have also NoSQL databases. You can have CouchDB, MongoDB for structure that can be used for structured and unstructured data. You can have files also for structured and unstructured data. Data lakes usually are storages that are defined in big data contexts. So where actually you want to have one place where you mainly store the raw data in order to be processed afterwards. Imagine that, for example, you want to match the Bitcoin value over the days and the sentiment analysis on the Twitter accounts during these days. These are completely different kinds of data. Maybe what you want to do is putting all of them into one single place, that is what is defined the data lake, and then processing them afterwards. And then also message queues, as I was anticipating before, that are mainly used when you have high velocity data, where you, when basically you have, you can have, that can be used in IoT contexts or in many other contexts where you have high velocity production of data. And usually, of course, when architecting a data management solution, the storage choice or even choices depend on the nature of data, and also on what you want to do with this data once it's been stored. So what is the kind of processing that you want to apply to such data? And now we come to the data processing. So the data processing actually, it's actually the phase where we want to somehow work with the data. And there are mainly two main activities, let's say, forgive me the word, that you want to apply to the data. One is the transformation, because imagine that you have different sources with different formats, and actually you want to correlate the data within each other. You need probably to transform them. So you need somehow to modify them in order to reach one single format that can be, or more formats that can be compared or correlated with each other. And this is one part, and actually is the T letter in the ETL and ELT methodologies, where ETL is extraction, transform, and load, while ELT is extraction, load, transform. And actually, the only difference is that in the ETL, you first extract, then transform, and then you load the data. So you write the data into a specific target, while in the ELT methodologies, you extract the data, you load it somewhere, so in a storage that can be used for your for the processing, and then you transform it. But the transformation phase is also used for extracting information from the data. So actually, this is one of the main goals of the data management platform, as I was anticipating before, because actually the main goal is extracting information from the data. And can be, for example, basically is the application of a computation logic. So computation logic can be, for example, computing statistics over the data, knowing how many customers bought this specific product in a specific amount of time. But you can also extract information that is not that visible and that easy to understand. For example, you want to understand a pattern. A pattern can be, for example, and they will also do this example afterwards. Let's say that you have different devices. And these devices are producing a lot of data, and you want to predict when these devices will break. And so you want actually to create this kind of prediction in order to anticipate the breaking of these devices for performing what we can call a predictive maintenance. So actually you want to anticipate, you want somehow to predict the future, okay? And this is actually another form of processing of data. This is why here I said application of computation logic, standard or machine learning based. Now, once you have all this information, so once you extract this information from the data, you need to do something with that. Now, doing something with that can mean, for example, creating a report, okay, or exposing the data, the information that you actually extracted from data to different kinds of applications. For example, mobile applications or even physical devices themselves. So the sharing part means the availability of systems and methods to expose the data and expose the information to other systems, okay, in order to facilitate the integration between them. And actually, so here, as I said here, so for example, it can be the most intuitive part is the creation of REST APIs around data. So imagine, for example, that you have a table where you have all your customer informations. You can create a layer of APIs, so a layer of services that enable you to get all the customers, to delete one, to insert one, to update one, what are called the most common CRUD operations. But of course, you can create much more complex behaviors. But it is not only that. Also, the population of a data mart, as I was saying, for example, creating reports on top of it, can be seen as a form of sharing data. And even programming an EEPROM of a device, an EEPROM is an erasable programmable memory. You know? So I just want to invite you to think that when we are talking about sharing, we are talking about everything that can help the consume of the information that we are extracting from the data. Then at the end, we have the governance. And basically, the governance nowadays is more and more important, especially now that we have all these different compliances like GDPR in Europe, POP in South Africa, and more and more. Because actually, right now, we have people in the companies that are accountable for the data. So actually, we have people like, for example, the CDOs that needs to always know where the data is coming from, where it's going, who has access to data, how this data is used, and so on and so forth. So an effective data management platform right now always need to include tools for performing data governance. And actually, this is achieved in most of the cases using what can be defined metadata management tools. So that are tools that are mainly extracting data around the data. So tools that can give you, for example, the holistic view of your infrastructure. So taking care of your hundreds of sources, hundreds of processing, hundreds of reports that you can have, putting them together in one holistic view, and giving also the instruments to people that are accountable for the data, instruments, for example, for performing actions like data lineage. So understanding, for example, where the data, starting from the data that can be, for example, a dimension in a report, where this data is coming from. And so understanding all the different phases that brought a specific data to become the dimension of the report. But it's not only that. Data governance can be also related, for example, for giving, when you want in your company to give a common understanding of terminologies. Because, for example, data can be interpreted in different way depending on the. Imagine that you have a company that is the result of a merger and acquisition of many companies. Probably everyone has the concept of address, for example, but or many others. But actually, what is important is having a common understanding in the company, the broad company, of the single terminologies. So a data governance platform can be, the data governance part of the data management platform can be used also, for example, for creating dictionaries, glossaries around your data, giving them a single understanding of what's going on. Now, this is one over many reference architectures that you can find on the internet. Here, I just placed one that is that is taken by Wikimedia. And actually, if you see this picture, and I invite you also to find other reference architectures that you can find on the web, you will see that in every architecture, there are all these elements that I was talking before. So here you can see that there is the storage, there is the acquisition, here there is the service, the sharing part. Also here, this is the sharing part. There is here, you can see that there is the data quality. So here we have the profiling part. Here we have this is a consumer, for example, the consumer of the data, also the analytical environment that can be part of the processing as well as part of the consumers. So for example, your business intelligence tools. And here, for example, you have the governance part. So actually, I invite you to check the reference architectures that you have, that you can find on the web, also on some probably projects that you had in your, that you already had in your company, and actually to extract from these architectures all these different topics that I was telling you. And you will realize that most of the cases, they are all there, okay? Now, I want to spend a little, let's see, just this slide around big data, because as I was saying before, there is technologies, when we are talking about data management, significantly change depending on the nature of the data. So I was before, I was talking without defining it, standard data and big data. But let me just spend a few words about, so probably refreshing for most of you, some concepts of what is big data. So basically, big data are mainly characterized by what are called the 4V. 4Vs, because actually big data is not just a lot of data, okay? A lot of data is the volume part of the data. But actually, when we are talking about big data, we are talking also about variety. So different forms of data. As I was saying, imagine that you want to correlate the Bitcoin values with the Twitter accounts, or you want, for example, to check another use case, the video streams that are in, for example, in a stadium during a football match, and the Facebook messages that are in real time produced during the match itself. This is, I mean, here we are talking about correlating really different data formats in a very also small amount of time. And so this is when we are talking about variety. Variety, so it means having different formats of your data. Velocity. Velocity is another part. As I was anticipating before, on one end, we can have situations where we have 100 records produced in one day. But on the other hand, we can have really even billions of records that are produced in one single day, especially if they are coming from devices. This is something that indeed is very sensitive when we are talking about IoT, so Internet of Things. And then the veracity. The veracity is basically the level of trust that you have on the data. And also there, when we are talking about big data, we can have data that can be so raw that is not trustable unless you don't perform really heavy operations of profiling, of transformations, so of processing, and so on and so forth. So basically, when you have these four V's, even only one of them, they can be defined big data. Okay, so you can have also just a few records that are coming from sensors. Okay, and in this, every single row can be, for example, the value of a temperature sensor. Okay, and you can have even not that many in terms of volume, but imagine that they are coming with a speed of one every millisecond. This can be defined big data as well. Now, when we are talking about big data technologies, there are mainly two architectures that I'm going to present to you at very high level. The first one is the Lambda architecture. The Lambda architecture wanted to solve a big problem. And this big problem was how to have, on one end, let's say, long-time computation of data. Long-time computation of data means, for example, I want to create a machine learning algorithm that learns, as I was saying before, that wants to find the pattern of breaking of some devices, of some machines. Actually, you need one kind of storage that stores all the historical data. And then you need a machine learning algorithm that, based on the historical data, learns after how much time these machines and also after which conditions these machines broke up. But on the other hand, for example, you want to predict in real time what can be, so if a machine will break or not in a specific amount of time. So this is why the Lambda architecture wanted to separate what is called the batch layer, that actually is the layer that contains all the historical data, for example, in our case, and what is called the speed layer. The speed layer instead is the layer that contains the real-time data, so the high-velocity data. And basically, that means the Lambda architecture is always composed by one storage for the historical data, one storage for the speed layer, one processing system for the batch layer, and one processing system for the speed layer, one analysis layer. So, for example, the production of reports for the batch layer and one for the speed layer. So basically, everything is divided into one part is for the batch part. So, for example, historical data, and so for long time processing data. Well, the other one is for the high velocity data. So that can be the real time and near real time data. But actually here, if you think, well, I mean, it was realized that is quite, it can be quite complex maintaining a system like that. Indeed, this is an example of here you have different technologies that need to be used. So here you can see that, for example, this is an example of Lambda architecture. Okay, so you can have, for example, a Kafka queue that takes all the data and then that writes all of them into the batch layer. Imagine the historization of the data, for example. And then you can see that here there is the pre-compute views. You can see it, for example, the machine learning algorithms applied to such data. And then you have the second part instead that is done only for the real-time or near real-time data. So it's like if you have two systems, they need to be orchestrated, of course, within each other. And in most of the cases, you have also two different systems that allow you to inspect such data. And so to inspect, for example, you can have also two different business intelligence tools. One for creating reports on the batch layer, and one just for creating reports on the speed layer. And sometimes you need to merge these results in order to put them together, also to compare them. And sometimes it might be a use case. So in order to overcome this situation, now more and more, and actually this is something quite cutting edge, even if it exists, I think it's been existing now for probably a couple of years, but only now, in these days, but really this year, at least personally, I started seeing application of what now is defined the Kappa architecture. And the Kappa architecture wants to overcome the problem of the Lambda architecture of having two different storages, two different processing layers, and so on and so forth. Having one single storage. And one single storage, of course, that can be used for both scenarios. For the long-time processing activities, like, for example, training a machine, so training an algorithm for machine learning, as well as the speed layer. So it means, for example, to predicting in real time, applying the rules that have been created by the training of the machine learning, the training of the algorithm, and using one single storage. So basically, the main principles of the Kappa architecture is that everything is a stream. Okay, and so actually batch operations are simply, let's say, slow streaming operations. Forgive me the simplification. We are talking about immutable data sources. So the raw data is persisted. What is very powerful of the concept is that somehow there's always a layer that is built on top of the raw data that allow you to keep track of the states of the data themselves, in order also to roll back to a previous state of the computation, as well as replaying different states starting from one specific state, or even let's say the state 0, that is the raw data as it came. The big advantage, of course, as I was saying, is only having one single analytics framework. Instead of having, for example, two business intelligence tools, you can have only one that is interrogating the same kind of storage. And then the replay functionality is what I just described. Now, why it's something that is quite cutting edge? Because the storage and the processing engines are quite new. And I'm pretty sure that some of you already heard about what is called Databricks Delta. That is the Databricks preferred technology in order to implement what they call lake houses, that are the evolution of data lakes. And actually lake houses are, and you can see them as the data lakes in Kappa architectures. So the data lakes that can be used for both batch and streaming processes. Then we have Apache OD, that is the open source project, and then Hive 3, that is the preferred technology from Cloudera. And actually what we have seen in the market is that Databricks and Cloudera are right now the biggest players when we are talking about Kappa architecture. Now, let me describe a bit, and it will be also here quite high level, what is the data management architecture with Talend. And also here, probably, you will see the same concepts that I was describing before about the data management platforms. So here, now I'm talking about an architecture that is purely on-premises. Purely on-premises means that the entire stack of the data management platform is installed on your premises. So actually there are, first of all, what you will need. And now, I mean, this is Talend, but for any data management platform, you will see that more or less the names are different, but the concepts are always the same, because you will always have a tool for implementing graphically let's call them integration artifacts, okay? So that can be standard jobs, big data jobs, big data streaming jobs, ESB routes, and so on and so forth. And then you will have other components. For example, in Talend, we have the Talend Administration Center, that is the part that allows you to orchestrate everything. So it's the administration center of your platform, where you can, for example, schedule the jobs, you can create users, groups, you can give authorization, authentications policies, and so on and so forth. Then here we have, in Talend, we have also the data preparation, that is the data preparation portal, that is where you define rules that you want to apply to the data. And here, actually, this is a part of the transformation phase that we were talking before. And actually, in the data preparation portal, you have also profiling capabilities, and also in the studio you have, where so the data quality part is covered. We have the data stewardship portal, that is actually where stewards, that are so users accountable for actions on the data, can perform activities on the data. So also here, it can be seen as a part of the data quality, of the transformation part, and also the governance part, okay? And then here we have other concepts here. Now I'm not going in deep on this because this is more technical. So for example, just probably what is worth mentioning is the concept of job server. That is where that is this lightweight agent that executes the job that can be placed, for example, on top of an Hadoop cluster in order to run big data jobs. Another part probably that it's worth mentioning is the repositories, because in most of the data management platforms anyway, when you implement a job, okay, or let's say more generically an integration artifact, you will probably have a compiled version of this artifact, and also the source of this artifact, that can be pure Java code or Spark code like in Talend. But I mean, with other platforms, you might have also the source code in a specific proprietary language. But the concept is always that in most of the cases, in the modern data management platforms, you will have two different also storages, two different kinds of repositories. One will be the storage of your, let's say, compiled artifacts. In our cases, for example, for Talend is a Nexus server. And also you will need probably a source repository. So for the source version, can be Git, can be SVN, and so on and so forth. And usually a data management platform includes all of this. Now, as I was saying before, in the previous slide, we were talking about a non-premises architecture. So an architecture where we are installing the entire stack of the platform on premises. But nowadays, more and more, and also with Brian, we were seeing that in the region, this is like a new hype that is coming. More and more companies don't want to install, or better, they want to install as least softwares and services as possible on their premises, trying to outsource some systems in what is called the cloud. Okay, so actually leveraging the software as a service pattern. For example, in Talend, what we have that some parts of the stack are provided as a service and that are running in our cloud. So you have, for example, the administration, say what was called the administration center of the on-premises installation. Call it can be run also in our cloud. So that means that you can use an already working instance of what we call the Talend Management Console, simply having your login and password, so without installing it, as well for the data preparation, the data stewardship, and many other tools. We also have, for example, there are some companies that don't even want to install the GUI for implementing the integration artifacts. They want to have everything completely as a service, and so for that we also implemented. We are also providing what is called the pipeline designer, that is this completely SaaS-based tool for implementing integration artifacts. Here I placed also Databricks and Cloudera, because another very, I think, appealing concept is also externalizing the computation power. So that means that, for example, let's say that up to, let's say, 10, probably 8 years ago, if you wanted to have a big data, if you wanted to process big data with the Spark, you needed to have your own Spark cluster that could run on your premises, purely on your premises, or could run, for example, in different machines provided by the cloud providers, Amazon, Google, and so on and so forth. Instead, with Databricks, you can, for example, you can use Spark as you go. So you can create your own Spark cluster that is running on their specific cloud, and then you can use this Spark cluster only, so without installing anything, only for processing your data. And we are interacting with it. And what is even more appealing, and it applies also to Cloudera and are both, is that they realized that it's very important that data management platforms are working together with the data science world. And so actually what you can do in both environments, you can also you can also create your Python notebooks, because we know that Python is probably the best technology right now around data science, actually removing the gap between the data management platforms, so that the people that are actually working on integration, transformation, and all the concepts that I was describing before, and the data scientists that actually don't care about where the data is coming from. They just care about how can they extract information, how can they teach a specific machine learning algorithm how can they train a specific machine learning algorithm for fulfilling some specific needs. And actually with Talend, you can do all of this. So let's say that it's fully integrated. As I said, now I'm talking about Talend because, of course, it's the platform that I know the best. But I'm telling you, more or less now the main platforms, even if the names are different, they are working in a similar way. Now, these are the really last 3 slides. I will go very, very quick because I can see that we have just 3 minutes. Actually, when you talk, let's say, inside your company or also to your customers or prospects about cloud, actually there is always a lot of resistance because let's say that we are so used to think about cloud, when we are talking about cloud, to think about an external storage, so our data out of our home, so we don't know where it's going. Actually, it's not anymore like that. Because what we can do in Talend, and I'm pretty sure that also in other platforms it can be done. Actually, you can have or a pure cloud architecture, where actually it's true that the data is stored in a specific platform, in a specific cloud environment that is owned by someone else, for example, Talend, or can be also owned by different providers. Imagine that you have, for example, you're using the SaaS version of Oracle, or you're using a Snowflake, and so on and so forth. So actually data is stored and persists somewhere else than your premises. Actually, you can use what we call the cloud engine. That is an agent that runs in a specific cloud, in our cloud, for example, and that actually takes care of extracting, of running the logic of your integration artifacts. So, for example, reading data from different sources, processing them, and then writing them to other sources. Okay, but actually, right now, more and more, actually, since, as I said, imagine that you have a banking environment, an insurance environment, where people don't want at all to have the data getting out of their premises. Actually, what you can do is considering that you can still have some services outsourced. So some services that are running as a service on other clouds, like our clouds. But actually, you can have the execution engines, here are called in Talend terminology, remote engines, that are running on your premises or even in your virtual private cloud, that are actually the ones that are executing the job with you, keeping, and this is very important, the data in your premises, so behind your firewall or in your virtual private cloud. So basically, you have different options always to architect a data management platform. So the data management platform, just to recap, as I was saying in the beginning, is composed by the different phases, as we said, ingestion, the data quality, the transformation, the sharing, the storage, of course, and the governance part. And every architecture that you will see or that you will put in place, you will realize that will have always these different parts together put in place. And so we're actually, so you will simply see that there will be simply different implementations with different terminologies, but the concepts will be always the same. What is then important is always to consider that the main 2 branches that we have are standard data and big data, because depending on that, you will have different terminologies and different methodologies that you will apply. And then after that, there will be always the main question, on-premises or SaaS? And the answer can be also something in the middle. And what here I defined as a hybrid approach. And this is basically what I wanted to describe to you. I hope I was clear enough. I know that there were a lot of concepts and there was a very high level, but unfortunately for this amount of time, probably I could have run like a 10 hours meeting, but I hope that it was interesting enough for you. I mean, if you have any questions, I will be happy to answer if I can.
All right, so we don't have any further questions. Thank you so much all for joining, and thank you so much, Luca, for this very informative session. This is the second session in this series. There are 2 more sessions that are remaining, that next week and next week. We look forward to seeing you all there. Thank you so much, Luca, again.
Thank you, guys. Thank you. It was a pleasure. Of course, let me know if you have any question. You can also drop me an email. I will be happy to answer.